Hi, this is the solutions to the 2020 Advanced Maths HSC paper. In this video, I'm going to look at section 2, booklet 2. Question 21. Hot tea is poured into a cup. The temperature of the tea can be modelled by capital T equals 25 plus 70 multiplied by 1.5 to the power of negative 0.4 T. Capital T is the temperature of the tea, lowercase t is the minutes after it is poured. What is the temperature of the tea 4 minutes after it's been poured? Nice easy one to begin with. Capital T is equal to 25 plus 70 multiplied by 1.5 to the power of negative 0.4 times 4. And straight into the calculator will give you the answer. Part B, at what rate is the tea cooling 4 minutes after it's been poured? So this is the derivative. We can tell that because it says rate. So rate of change. dt is what we want. Okay, looking here at our formula, we're going to go term by term. So the derivative of 25 is 0, it goes. Then I've got this 70 and then multiplied by 1.5 to the power of negative 0.4t. And up here you can see that I've got a bit from the reference sheet that's going to help us. So firstly, the 70 is going to hang around, and now I need to do the derivative of 1.5 to the power of negative 0.4t. Now, we really have got t is equal to a to the f of t here. And so our derivative dt is going to be ln a f dashed of t and then multiplied by a to the f of t. And we can tell that a is going to be equal to 1.5 and f of t is going to be equal to negative 0.4t, and we're going to want the derivative of that. So let's do that. Okay, we're ready to construct this. So 70 multiplied by, following our formula, ln a, so that's ln 1.5, multiplied by f dashed of t, which is negative 0.4, multiplied by a to the f of t, so it's 1.5 to the power of negative 0.4. We could put the t in there, but we know that we want t to equal 4, so we'll just multiply it by 4, and then into the calculator will give you the answer. Part C, how long after the tea is poured will it take for the temperature to reach 55 degrees? So again, we're going to use this equation. This time, capital T is equal to 55. So we're going to get 55 is equal to 25 plus 70 multiplied by 1.5 to the power of negative 0.4 t. And solving this equation is going to involve logs. Basically, I want to isolate this part here. So I'm just going to take our 25 over to begin with. It becomes negative 25, so 30 is equal to 70 multiplied by 1.5 to the power of negative 0.4 t. And then divide both sides by 70 to get rid of that. So we have 3/7 is equal to 1.5 to the power of negative 0.4 t. Now I could pull this out of index form into log form, but it's not really going to help me very much, so I'm going to take logs of both sides. So I'm going to go ln of 3/7 equals ln 1.5 to the negative 0.4 t. This, of course, is our third log law. This index comes down the front. So ln 3/7 is equal to negative 0.4 t ln 1.5. Divide both sides by negative 0.4 ln 1.5. That will give us t by itself. So that cancels. That cancels. So t is going to be equal to, let's grab my calculator, ln 3/7 divided by negative 0.4 times ln 1.5, and that is 5.22 minutes. Question 22. The diagram shows a regular decagon, 10-sided shape with all sides equal and all interior angles equal. The decagon has center O. The perimeter of the shape is 80 centimeters. So we know, because it's a regular shape, that AB multiplied by 10 must equal 80. And so AB is equal to 8. By considering triangle OAB, let's draw a bigger version of that. calculate the area of the 10-sided shape and give your answer to 1 decimal place. Right, so we're going to use the formula A is equal to a half AB sine C. We've got a bit of a problem though. We don't know this angle and we don't know these sides, so we need to work those out. Let's start with the angle. That's pretty easy. So here's theta. So theta times by 10 must equal 360. So theta is equal to 36 degrees in there. But how are we going to work out these sides A and B? Well, because we've got an isosceles triangle, if we put a perpendicular up here, firstly it's going to cut this side in half, so that's going to be 4. It's also going to bisect that angle. So let's draw a bigger version of it so you can see what's going on. We've got 4 there, we've got 18 degrees here, and I'll just call this side x. And we've got sine. Sine 18 is equal to 4 on x. X is equal to 4 on sine 18, which is, I'll grab my calculator and make sure I'm in degrees. I am. 4 divided by sine 18 is 12.944. Okay, we're ready to construct the area. So area is going to be a half times A and B are both 12.944. So I'm just going to do 12.944 squared times by sine of the angle, which is 36. And I want to multiply all of that by 10. I'm going to put that into the calculator. I am going to get 492.4 centimeters squared. Question 23. A continuous random variable x has the following probability density function. F of x is equal to sine x for 0 is less than or equal to x is less than or equal to k, and 0 for all other values of x. Find the value of k. So we know that the integral between 0 and k of f of x dx must equal 1, because the sum of all probabilities of any probability density function must equal 1. So we're just going to do some integration. The integral of sine x is a negative cos x, and we want it in between 0 and k, and that equals 1. Substituting in the k, take away negative cos 0 is equal to 1. Be careful here, cos 0 is 1. So we've got negative cos k plus 1 equals 1. Cos k is equal to 0. And so k is equal to inverse cos of 0. You can either do that on your calculator or a quick sketch. Here's 0 here, it's pi on 2. And that's our answer. There. Alright, part B. Find the probability that x is less than or equal to 1. So now we're going to set up our integral again. We're going from 0. This time our upper limit is 1. Sine x dx. We've already done this integration. Negative cos x in between 0 and 1. We're going to substitute the 1 in. Take away negative cos 0. It's going to end up being 1. Take away cos 1. Make sure your calculator is in radians. And we're going to end up with 0.4597. Question 24. The circle x squared minus 6x plus y squared plus 4y minus 3 equals 0 is reflected in the x-axis. Sketch the reflected circle showing the coordinates of the center and the radius. Alright, before we do any sketching, we need to complete the square to work out what the center and the radius of the original circle are. So x squared minus 6x, I'm going to leave a gap when I complete the square, plus y squared plus 4y, leave another gap, and I'm going to take this 3 over the other side to get it out of the way. Okay, so when we complete the square, we look for the term in x and the coefficient of that term, which is negative 6. And we are going to halve it, square it. Now, because we are squaring it, we don't actually care that it's a negative. So I'm just going to say it's 6. Half of 6 is 3. 3 squared is 9. So 9 goes in here. Now look for the term in y. The coefficient is 4. Half of 4 is 2. 2 squared is 4. Now we need to adjust it because we can't just add numbers to one side of an equation without balancing it. Right, we are ready to complete the square. This is x minus 3 all squared plus, and this here is y plus 2 all squared is equal to 16. So the center of the original circle is what makes 0 here, which is 3. What makes 0? Negative 2. The radius is the square root of this number, which is 4. All right, if we were sketching this circle, we would plot the center, which is here, and draw a radius of 4, but it has been reflected in the x-axis, so it's going to flip up this way. It's going to come up here, and the center of the reflected circle will be 3, 2, same radius though. And you can do a better diagram than I'm going to do, but roughly it's going to, oh dear, look something like that. Looks like an alien. 3, 2, and radius is equal to 4. Question 25. Landscape gardener wants to build a garden bed in the shape of a rectangle attached to a quarter circle. Let x and y be the dimensions of the rectangle in meters as shown in the diagram. The garden bed is required to have an area of 36 meters squared, and the perimeter is to be as small as possible. Show that P is equal to 2x plus 72 on x. All right, let's start with the perimeter. So from here, it's going to be x plus y plus x plus y plus that quarter circle. Right, so let's write that down. Perimeter equals x plus y plus x plus y plus a quarter times 2 pi r, and in this case r is x, 2 pi x. Tidying it up, we get 2x plus 2y plus pi x on 2. Right, we want to get rid of this y, so let's use the other piece of information we have, which is the area. The area of the rectangle is xy. The area of the quarter circle is a quarter pi r squared, which is x squared. So our area is going to be xy plus pi x squared on 4, and that equals 36. Making y the subject, xy is equal to 36. Take pi x squared on 4 and dividing through by x, y is equal to 36 over x. Take away pi x squared on x is just x, so let's cancel that out, on 4. And now let's substitute that into our perimeter equation. 2x plus 2 lots of all of that, 36 on x, minus pi x on 4, plus pi x, that's not a squared, is it? No, on 2, equals 2x plus 72 on x. Take 2 pi x on 4 is pi x on 2, plus pi x on 2, and I believe we are done. 2x plus 72 on x. Now don't forget that if you can't do this part, you can use it to have a go at part B. Find the smallest possible perimeter of the garden bed, showing why this is the minimum perimeter. Alright, this is a max-min question. We need to do the derivative. So let's tidy this up into index form firstly. And let's do dp dx. Alright, derivative of 2x is 2 plus 72 multiplied by negative x to the negative 2. Tidying it up, I get 2, take away 72 on x squared. And with max-min questions, I want that to be equal to 0. So 2 is equal to 72 on x squared. X squared is equal to 72 on 2, which is 36. X is going to be equal to plus or minus 6, but x can't be negative. Therefore, x is equal to 6. Now we need to show why this is a minimum, so let's do the second derivative. d squared p dx squared is going to be equal to, the 2 goes, we've got negative 72 multiplied by negative 2x to the negative 3. Tidying it up, I get 144 on x cubed. At x is equal to 6, the second derivative is equal to 144 on 6 cubed, which is 2/3, which is greater than 0, therefore it is a minimum. So don't forget to justify it. Now we haven't actually answered the question. Find the smallest possible perimeter. So just to finish off, we now need to substitute our 6 into this here. So 2 times 6 plus 72 on 6 is 12 plus 12, which is 24 meters. Question 26. Tina inherits $60,000 and invests it in an account earning interest at a rate of 0.5% per month. Each month, immediately after the interest is paid, Tina withdraws $800. The amount in the account immediately after the nth withdrawal can be determined using the recurrence relation. N is 1, 2, 3, etc. A naught is 60,000. Use the recurrence relation to find the amount of money in the account immediately after the third withdrawal. So we want A3. I'm just going to have to do a bit of arithmetic here. So A naught is 60,000. A1 must be A naught multiplied by 1.005, take 800. So I'm just going to put this in the calculator. We have got 60,000 times 1.005, take 800, which is 59,500. And then A2 would be equal to A1 times 1.005, take 800, which is, I've still got that in the calculator, so I'm just going to hit times 1.005, take 800, which is 58,997.5. And then finally A3 is A2 times 1.005, take 800, times 1.005, take 800, which is, and this is our answer, so I'll put a $sign and to 2 decimal places, 58,492.49. Part B, calculate the amount of interest earned in the first 3 months. So we want to take this part here, and then this part here, and this part here, and work them out. But I don't want to multiply them by 1.005. I only want the interest part, which is the 0.005 bit. So I want 60,000 times by 0.005 plus 59,500 times 0.005 plus 58,997.5 times 0.005, and if we put that into the calculator, we get $892.49. Question 26. Calculate the amount of money in the account immediately after the 94th withdrawal. So we want A94, and we're going to use this to get there. I'm going to need a bit more space though. Right, so we want A94. So I'm going to start off with A94 is equal to A93 multiplied by 1.005, take away 800. And I'm going to work through the first 3 terms, just substituting in so I can work out the pattern. A93 would be A92 multiplied by 1.005, take 800. So that's that bit there, times 1.005, take 800. And let's expand this out. So this part times this is A92 times 1.005 squared, take 800, times 1.005, take 800. Now let's put in A91. So that's A91, I'm just following this each time, times 1.005, take 800. So that's that, times 1.005 squared, take 800, times 1.005, take 800. And expanding the brackets, this times this gives us A91 times 1.005 cubed, take 800, times 1.005 squared, take 800, times 1.005, take 800, and I'm just going to tidy this up. A91 times 1.005 cubed, take 800. So I'm going to take that 800 out of this. I'm also going to turn it around, so make sure this makes sense to you. Just have a look what I'm doing, because that's going to make it easier in the long run. So I've got a negative out the front of those brackets, so all of these signs are going to turn into pluses. And I've turned it around so that it's 1 plus, etc. All right, we're going to follow this pattern. So I don't want A91, I want A0. So you can see this 91 and the 3 adds up to 94. So this must be 1.005 to the power of 94. Take away 800. 1 plus 1.005 plus 1.005 squared plus dot dot dot. This is 1 less than that number there, so that must be 1.005 to the power of 93. And of course A0 is equal to 60,000, and we're going to multiply that by 1.005 to the power of 94. Take away 800, and here we have a GP, or geometric progression, that we need to sum. So the first term is 1, R is equal to 1.005, and N is equal to 94. So it's 800 multiplied by A is 1, R to the power of N, take away 1, all over 1.005, take 1. Okay, we're just going to put that into the calculator. Be careful with the 1.005s. Make sure that you put in enough zeros there. Our answer is $187.85. Question 27. A cricket is an insect. The male cricket produces a chirping sound. A scientist wants to explore the relationship between the temperature in degrees Celsius and the number of cricket chirps heard in a 15-second time interval. Once a day for 20 days, the scientist collects data. Based on the 20 data points, the scientist provides the following information. We have a box plot for the temperature data. We're told the mean temperature is 0.525 degrees below the median, and a total of 684 chirps was counted when collecting the 20 data points. The scientist fits a least squares regression line using the data x, y. X is the temperature in degrees Celsius, y is the number of chirps heard in a 15-second time interval, and here is the equation of the line. B is the slope. The least squares regression line passes through the mean point. X bar is the sample mean of the temperature data, Y bar is the sample mean of the chirp data. All right, now we need to work out what B is equal to, and we're going to do that by finding the mean point and substituting that in and solving for B. So we have to work out what X bar is, the mean temperature, and what Y bar is, which is the mean number of chirps. We're told the mean temperature in the data set is 0.525 degrees below the median temperature. From the box plot, we know that the median is going to be 22. So X bar will be 22, take away 0.525 is equal to 21.475 degrees. Now we need the mean of the chirps. So Y bar will be the total number of chirps divided by the number of data points, which is 20. So 684 divided by 20, which is 34.2. And there's our mean point. So 21.475, 34.2. Let's substitute that into the least squares regression line. So 34.2 is equal to negative 10.6063 plus B, we don't know, times by 21.475. And just solving this equation, taking that negative 10.6063 over the other side and adding it to the 34.2, just grabbing my calculator, 34.2 plus 10.6063 is 44.8063 is equal to B times 21.475. Taking this times 21.475 over the other side, B is equal to 44.8063 divided by 21.475, which is B is 2.086. The question here, calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius. So x is equal to 19. So we just substitute in y is equal to negative 10.6063 plus 2.086 times by 19, and into the calculator we get approximately 29 chirps. Now, for the record, what a stupid question. One thing that you can do, if you can't work out what B is, then write something down. Just write B is equal to something rather sensible, if you can manage to figure that out. And then use that to work this part out, and you'll get part marks. You'll get follow-through error. So that's one way to get around it, but a lot of reading to do in this question to be able to figure out what on earth to do. So yeah, good luck if they give you something like that this year. Question 28. In a particular country, the hourly rate of pay for adults who work is normally distributed with a mean of 25 and a standard deviation of 5. Two adults who both work are chosen at random. Find the probability at least one of them earns between $15 and $30 per hour. So we let X be that they earn between $15 and $30 per hour. All right, normal distribution. Let's start there. So our mean is 25. Adding on our standard deviation. I'm just going to do it twice in both directions. Then we just got to construct a probability here. We want between 15 and 30. So this part all the way up to there. We know that within 2 standard deviations, the mean is 95% of the population. Within 1 standard deviation of the mean is 68%. All right, so we know this part, that's 68. We need to work out that bit. That bit and this bit will be 95 take 68, which is 27. And because it's symmetrical, this part then must be 13.5. So the probability of X is going to be 68% plus 13.5%, which is 81.5%. And I know that I'm going to need the complementary event, so I'm just going to do that now. 1 take away 81.5%, which is 18.5%. All right, now this is a really cool question because it's got probability in it as well as normal distribution. Two adults, both work are chosen at random. Find the probability at least one of them earns between that. So the probability at least one earns X is the same as the probability, sorry, it's 1 take away the probability that neither of them earn that. And so that's going to be 1 take away 18.5% all squared, which is what? 96.6%. Part B. The number of adults who work, so let's call that W, is equal to 3 times the number of adults who don't work. One adult is chosen at random. Find the probability that they work and they earn greater than $25 an hour. All right, these are independent events, that they work and that they earn greater than $25. So we can do the probability that they work multiplied by the probability they earn greater than $25. Now remember, from our normal distribution that we drew on the previous question, we had a mean of 25, and so the probability that they earn greater than $25 is just a half. So we just need to find the probability that the chosen adult works and then multiply it by half. So for every person who doesn't work, 3 people work. So the probability that the chosen adult works is 3/4. And 3/4 times a half is 3/8. Question 29. The diagram shows the graph of y equals c ln x, and c is greater than 0. Show that the equation of the tangent to y is equal to c ln x at x equals p is given by this. All right, equation of a tangent, we are doing the derivative. So we've got y is equal to c ln x. Our derivative, dy dx, is equal to c on x. We want it at x equals p, so at x is equal to p, the gradient will be c on p. We also need to know the y-coordinate, so at x is equal to p, the y-coordinate is c ln p. Now into our formula, y take away y1 is equal to m, x take x1. So y take, y1 is this, c ln p equals m, which is here, c on p, x take p. Alright, we're just going to tidy this up to get that. So y take, actually I'm going to do equals, we'll expand this out, c on p x, take away c, and then take that over, actually we're done, plus c ln p. There it is. Part B, find the value of c such that the tangent from part A has a gradient of 1 and passes through the origin. Now we worked out the gradient before, it is c over p, so that's equal to 1, so c is equal to p. Now let's substitute in the origin, because we know it passes through there, and we'll end up with an equation we can solve for c. So 0 is equal to c on p times 0, take away c plus c ln p. Well, it's gone. So 0 is equal to negative c plus c ln p. Now we know that c is equal to p, so 0 is equal to negative c plus c ln c. And just tidying that up and factorising, I get c outside of ln c take 1 is equal to 0. So either c is equal to 0, which it can't be, or ln c is equal to 1. So this is the one we're going to solve. Just taking that out of log form, we're going to end up with c is equal to e to the power of 1, or just e actually. And so that's our answer, since we should write c is greater than 0. Question 30. The diagram shows two parabolas, y equals 4x minus x squared and y equals ax squared, and a is greater than 0. The two parabolas intersect at the origin O and at A. Part A, show that the x-coordinate of A is 4 over A plus 1. Right, so we want to find point of intersection of these two curves. So we'll take this, and we'll try and find the x-coordinate. So ax squared is equal to 4x take x squared. Taking everything over the left-hand side, we've got ax squared plus x squared, take away 4x equals 0. Factorising, x squared a plus 1 minus 4x is equal to 0. And factorising the x out, I get this, a plus 1, x take 4. Either x is equal to 0, which we know, or a plus 1 x minus 4 equals 0, a plus 1 x is equal to 4, x is equal to 4 over a plus 1. Part B, find the value of a such that the shaded area is 16 on 3. So we need the integral between 0 and 4 on a plus 1. The area under this top curve here, which is 4x take x squared, take away the area under this curve here, which is ax squared, dx. Now I'm just going to tidy this up before we integrate. 4x, I just want to collect those x squared terms together. So 1 plus a dx equals, integrate. Integral of 4x is 4x squared on 2, which is 2x squared. Integral of x squared is x cubed on 3, and this is just a constant. Between 0 and 4 on a plus 1. Substituting in the 4 on a plus 1. So 2 times 4 squared is 16 on a plus 1 all squared. Take away 4 cubed is 64 on, we've got a 3 there, a plus 1 cubed multiplied by 1 plus a, take away 0, etc. That cancels with one of those. So we've got 32 on a plus 1 all squared, take away 64 on 3a plus 1 squared, and that has to be equal to 16 on 3. All right, first thing I'm going to do is something sneaky. I'm going to put a 3 here and multiply top and bottom of this term by 3, so that gives me 96 there. And that way I can cancel out these 3's. Gone. All right, we have got 96 take 64 all over a plus 1 all squared is equal to 16. And it's coming up over here. 96 take 64 is 32 is equal to 16 multiplied by a plus 1 all squared. A plus 1 all squared is equal to 32 divided by 16, which is 2. A plus 1 is equal to the plus or minus the square root of 2. A is equal to negative 1 plus or minus the square root of 2, but A is positive. Therefore, A equals negative 1 plus root 2. Question 31. The population of mice on an isolated island can be modelled by this function. T is the time in weeks, so it's between 0 and 52. The population of mice reaches a maximum of 35,000 when t is 13, a minimum of 5,000 when t is 39. The graph is shown. What are the values of A and B? So A is the amplitude, it's the height of the wave. B is how far above the horizontal axis this center of the motion is, or the equilibrium point, whatever you want to call it. So how far we've pushed this up. All right, let's find the difference here. 35,000, take away 5,000 is 30,000. And if I take that 30,000 and divide it by 2, I'm going to end up with the amplitude, which is 15,000. So that's A. Now, if I take this 5,000 here, it's not drawn to scale this, and add on that amplitude, I'm going to get this equilibrium position. So 5,000 plus 15,000, which is 20,000, is going to be equal to B. Part B. On the same island, the population of cats can be modelled by this function here. Consider the graphs of M of t and C of t. Find the values of t between 0 and 52 for which both populations are increasing. Now we're not going to attempt to graph this on this same graph here, because look at the scale. We've got between 35,000 and 5,000, whereas here the numbers are much smaller. So I'm going to draw a separate graph. Before we do, let's have a look where the mice population is increasing. It's here and here. So between 0 and 13, and between 39 and 52. Okay, let's have a go at trying to graph this. All right, we've got cos, that's our first point. And we've got negative cos, can you see that? So I'm actually, instead of drawing positive cos, I'm going to draw it upside down, like this. We have the same period as the mice population. So it goes between 0 and 52. So that's 26 there. What else do we know? It has an amplitude of 80, so that's negative 80 up to positive 80. We have a vertical shift of 120. So instead of 80 up here, 80 plus 120 is 200. And negative 80 plus 120 is 40. So I'm just going to move that axis. I hope that works. It does. So down it comes. Down here, and I want the 26 there and the 52 there. All right, we've got almost all of it done except for the hard bit, which is a phase shift. We can see here the whole thing is going to be shifted over 10. So instead of starting at 0, it's going to start at 10. This is going to be 10. This will be 36. This will be 62. I might put these ones in as well. They would have been 0, 13, 26, so this will be 23. 26, 39, so 49. All right, now it's not entirely how it works because I haven't put the axis in. This axis really needs to move over, but we can kind of see where this thing is increasing, can't we? From here all the way up to here. So I don't really need to continue the graph on. So in fact the cats are increasing between 10 and 36. So where is the commonality between these inequalities? That's out. Between 0 and 13 the mice is increasing, and between 10 and 36 the cats are increasing, so both populations are increasing between 10 and 13. Okay, last question. Find the rate of change of the mice population when the cat population reaches a maximum. Now we could take this function here and find the derivative of it. Put it equal to 0, find the turning points, and then maybe find the second derivative and figure out which one's the maximum. But we actually just drew the graph. I mean, it was a very rough graph, but it shows quite clearly that the cat population is maximized when t is equal to 36. So in fact, all we need to do is find the derivative of this, because it asks for the rate of change of the mice population, and then substitute in t is equal to 36. So m dashed of t is equal to 15,000. Sine, the derivative of sine is cos, pi on 26t, times by the derivative of the inner function, which is pi on 26, and then this plus 20,000, that'll go. Just tidying that up, I get 15,000 pi over 26 cos pi on 26t. And all we need is m dashed of 36, which is 15,000 pi on 26 cos pi on 26 times 36. And put it into your calculator. Now, do we want degrees or radians? And how can you tell? We want radians. The main way to tell is because of this pi here, and radians have always got pi in them, but almost all of your graphs are going to be in radians. So into the calculator, it gives us negative 643. Now initially you might think, what? Negative 643 mice? How's that possible? But it's not the number of mice, it's the rate of change of mice. So the number of mice is decreasing at a rate of 643 mice per week. And that's the end of the paper. Now you might be interested in some tips on how to study for HSC Advanced Mathematics, and if you are, then go to the link that's on the screen.